Greetings from IIT Kharagpur. Welcome to the first lecture of this course Physics of Nanomaterials, which I will be taking over the next few weeks. I am Professor Amrish Chandra, working as professor in the Department of Physics at the Indian Institute of Technology, Kharagpur, located in the eastern part of India. This course, Physics of Nanomaterials, will be given to you by me along with my teaching assistants Mr. Rahul R and Mr. Lalit Bharti. This is a 12-week course and we will have around 30 hours of lectures which will be delivered as part of this course. We will also have live sessions where you can ask your problems or any queries you have related to the course. There are also forums where you can raise your queries or give your opinions about the course, and we will get back to you with our answers and the way we are going to implement your suggestions if there are any in the future lectures. So, let us start with the first slide of this lecture. As it is customary, let me just give you a brief overview of the points that would be covered in this lecture. Many of us use these terms nanomaterials or nanotechnology in our daily vocabulary. But it is now time that we understand the exact definition of these two terms. We will start this lecture by giving you the definition of nanomaterials. As it is customary, we will give you the points that would be covered in this lecture. Many of us routinely use the terms nanomaterials or at least nanotechnology quite commonly in our daily vocabulary these days. But if you ask what is the definition of nanomaterial or how do you define nanotechnology, this is sometimes not answered properly. So, we must give a proper definition to these two terms, that is, what are nanomaterials and what is nanotechnology. Once we define that, then we will talk about confinement in nanostructures. What do we mean by confinement? So, that would be covered after the first few slides. As this is an introductory lecture, we will also give you various common synthesis processes that are used to obtain nanomaterials. You will find that the concept of nanomaterials is not new. It is being used for centuries after centuries after centuries. But as we evolve in our knowledge, we are understanding the reasons why the properties of nanomaterials change. That will be discussed in this lecture. And finally, we will discuss some of the applications of nanomaterials. I said some of the applications because in today's world the range of applications of nanomaterials and nanotechnology is so vast that no matter how hard I try, I will certainly miss some of the applications. So, we will cover some of the common applications of nanomaterials and why these nanomaterial based devices have very different properties to those obtained using bulk materials. The term nanomaterial is actually a convoluted word coming in from two terms, that is nano and material. What is a material? It is something which has a definite mass, volume and occupies space. You can have different types of materials. We have studied from our school days, you can have solid, liquid, gas, plasmas or combination of various types of these entities. So, materials are actually a combination of these forms of matter, each of them having specific physical and chemical properties. And what do we mean by the term nano? Nano, as per the International System of Units, commonly known as SI units, means 1 billionth, that is 10 raised to the power of minus 9. So, now if I ask you a question, what is a nanomaterial? Then a nanomaterial would be one which has dimensionalities in the range of 10 raised to the power of minus 9 meter or so. It is still not a complete definition, please note, I will come to it in few minutes. Just to look into the way the scales change. So, if you look into the typical examples, let us say we start from humans in the range of where the height is, let us say around 1.5 to 2 meters for an adult, down to a water molecule. You can clearly see that the scales go on changing. So, from 10 raised to the power of 0 to 10 raised to the power of minus 9 meter or so. So, this is where nano scale is actually lying, and the symbol is used as N. And then you know micro 10 raised to the minus 6, milli 10 raised to the minus 3, centi 10 raised to the power of minus 2, deci 10 raised to the minus 1 and so on so forth. Clearly, just by looking at this picture on the left, you can see if I compare the properties, then a human will have very different physical as well as chemical properties to those of smaller size molecules. Let us give you a very interesting example, and then we will come to the definition of nanomaterials. A human hair. Typically, a human hair, let us say we pluck one hair, then you will find that it is approximately 100 micrometer. You slice this human hair 100 times vertically, go on cutting a human hair vertically, you will come to 1 micrometer type. Then you cut it again 1000 times. So, you take that 1 micrometer piece of human hair and cut it 1000 times even more. Then the strand which you get would be approximately 1 nanometer. So, just by taking these two examples, you can clearly see that as we go from this scale, let us say 100 micrometer to 1 nanometer, the properties of these two are going to be different, just looking at this animation. How and why it happens, we will discuss as we build on this course. A very commonly used technique to see the surface properties or the morphology of these nanostructures is called scanning electron microscopy, that is SEM. We will discuss this technique in detail in the latter part of this course, but for the time being you can just take it as if we are taking a very high resolution picture, but at a very small scale also. So, you can zoom up to very small scale. So, if you take an SEM picture of a human hair, this looks something like this, and the dimensionality, that is the width which is shown in this hair, is approximately 100 micrometer. You can clearly see that there are structures which are forming on this hair. So, if the structure of the hair changes, what do we mean? This is commonly used in our daily talks, that the structure of the human hairs are very different. So, if you have a human hair which is, let us say, only 80 nanometers, then the width would be different. 20 nanometers, the width would be different. If it is smooth, then the surface roughness would be different. If it is not, then it would be slightly more, and therefore, the texture of the human hair also varies just by the dimensionality of the human hair. So, clearly, even before we go into the physics of nanomaterials, we can understand that the properties would be very different once we start going from bulk to nano scales. Let us take another example. This is a gold bar with this kind of dimensionality, that the height is around 20 centimeters and the width is around 10 centimeters. Correspondingly, you make nano gold, that is nano sized gold particles. You can clearly see that their structures would be different, and this is again an SEM picture of nano sized gold particles. So, you can on one hand see one big bar of gold, on the other side there are small particles which are coming together to give you a powdered form of gold, or you can compress it together to give certain shape. Clearly, at this level itself we can say, oh, the properties can be different. Are they different or not? That we will see in subsequent slides and lectures, but at this point we can just anticipate that there is a chance that the properties would be different when we go from bulk to nano size structures. So, a nanomaterial is defined as a material that has at least one of the three dimensions in the range of 1 to 100 nanometers. That means, if you draw a structure, let us say a structure, then this is x axis, this is y axis, this is z axis. Then at least one of the three dimensions have to be in the range of what? 1 to 100 nanometers. You will immediately ask, why 1 and why 100? Why not 1 angstrom to 150 nanometers? Why not 1 angstrom to 20 nanometers? You will see that this is coming in because most of the materials show change in their physical as well as chemical properties when they are taken below a range of 100 nanometers or so, and again when you take these sizes to less than 1 nanometers, that means you are moving towards atomic scales, then the properties once again show modifications, and therefore the standard which we take is in the range of 1 to 100 nanometers. But there are materials which may start showing change in their properties at around, let us say, 125 nanometers or so. Some may show it at 80 nanometers, but roughly this value is 1 to 100 nanometers in most of the materials, and therefore the definition is defined for this range. In this range you will see that the materials, more specifically these nanomaterials, will have modified properties which are quite unique compared to their bulk counterparts in terms of their physical properties or other properties like chemical, mechanical, electrical, optical, electrochemical, magnetic, and so on, will also show significant modifications as we go to lower dimensionalities. For example, gold nanoparticles are used in medical imaging, carbon nanotubes in electronics and various other strengthened composites, titanium dioxide sunscreens, paints and electrochemical systems. So, if you go to their bulk counterparts, they may not be used, but you reduce the size, they become useful for various applications. If you see just a very simple example, if you look into the wheat plant, you can get various products just by processing the raw wheat grain which you get. You can get semolina or suji, you can get wheat flour or atta, or you can even get refined form of this wheat flour which we call as maida. But the origin is where? Again in the grains. But just by changing the size of the particles which constitute the product which we are using, what are those? Let us say in this slide it is suji, atta or maida, the properties change significantly. That means the synthesis or processing techniques which are used to obtain the nanoparticles or nanomaterials also have significant impact on the properties of the final products. Sometimes we believe nanotechnology is a new field, but it is not. If we go back to our own literature, we will always see that we have been knowing that the use of silver spoon, we have been using the mortar pestle made up of gold for making the medicines. Why? Because if you see silver spoons, they are actually soft, and when you use it to feed a baby for the first time or in the first few months when the baby starts to eat, when the baby eats it with silver spoons, it is nothing to do with that it is something which is related to the rich class of people in the community. No, this is because every time you eat using a silver spoon, certain nanoparticles of silver is also being taken inside your body, which have antibacterial properties. These are non-toxic, they have cooling effects, and they are biocompatible. So, any new thing which a baby eats is taken as a foreign element by the body because it is going inside the body for the first time. So, there is a chance that the body may take the food as a bacterial infection or some kind of a impurity which has been ingested. So, silver actually then helps to stabilize the food and protects the body by delivering its antibacterial properties and gives the strength to the body to fight any bacterial infections which can be caused by the food which a baby is taking for the first time, or the body is still weak to accept the food which is being given to them. So, that is why, and this was known to our ancestors and it is well documented throughout the literature. Similarly, before I come to the various types of colored glasses which are used, we were also using the gold based mortar pestle to prepare the medicines. Same reasons, that every time you make a gold nanoparticle, then you mix it with medicine, the gold nanoparticles actually act as the carrier of medicine inside the body. They do not react with the body. They come out of the body after delivering the medicines. So, they were systems which were not, because they were so small, but they were attaching medicines to their surface and they were moving through the body, and the body was slowly digesting and taking the medicines. This was known to us for centuries and all our ancestors knew it, and that is why it is very commonly used even today in the traditional forms of medicines in India and many other parts of the world. Similarly, just by changing the size of the particles of silver, for example, you take silver nanoparticles of different dimensions, you can clearly change the corresponding color you will get. For a silver nanoparticle which is spherical in shape, has a dimensionality of 40 nanometers, you coat it on a glass, the glass will give you a dark blue color. You make silver nanoparticles, again spherical shape, the shape of the particles are very similar, but just change the size of the particles, take it to 80 nanometers, you will start getting celestial blue color. Take the shape of silver nanoparticles again as spheres, but make the particle size of 100 nanometers or so, you will start getting shiny gold kind of. So, just by changing the size of the particles, you can tune the corresponding colors and you coat it at different places of the glass, and the colors which will come out would be very different. This is again seen if you use gold nanoparticles. Use various forms, or you can use same morphology of different sizes, you will get different kinds of colors. So, either you can use gold spheres, change the dimensionality, let us say we go from 50 nanometers to 100 nanometers, you will go from yellowish green to coral kind of colors. But now you change the morphology, that means how the particle itself looks like. Let us say we go to prismatic type of colors, you will see that a red color comes out. So, what do we see? We can change the size of the particle while keeping the morphology same, or you can change the morphology, or you can change morphology and size of the particles to just change the colors of the nanoparticles which will be seen. You will find that this happens because the corresponding energy band diagram of these nanoparticles are changing as a function of dimensionality, and therefore, the band gaps are changing and hence the optical properties are changing. So, what is seen is actually explained by the corresponding physics of these nanomaterials. This is what I have already discuss, that is, simply by changing the size of a particle, the properties can be changed. People can ask, then why do not we go to pico or even smaller size particles? The reasons are very simple. The reason is that they are so small that at this level the manipulation of these particles are very difficult with the existing technologies we have, and the effect of quantum contributions are significant at such low dimensionalities, and therefore, a new gamut of parameters appear into the whole scenario, which have to be controlled, understood before the stable structures can be obtained of these pico or femtote sized materials. So, it is not that these materials cannot be synthesized, they are being seen, some effects are being seen in these size materials, but it will be some time before their usefulness would be felt by the common man in their daily lives. It is very interesting to know that Professor Richard Feynman is called as the father of modern day nanotechnology. In 1959-1960, he gave a lecture entitled "There is Plenty of Room at the Bottom," where he emphasized that as you will go on reducing the size of the materials, the structures, the unit cells, the devices, you are going to see lot of new properties. And hence he said that people should work on materials, devices, technologies which have very small dimensionalities, and that is why he is called as the father of modern day nanotechnology. And it also was clear from his lecture that this field cannot have contributions with people having one set of expertise. It is going to be an interdisciplinary field with collaborations coming in from people having expertise in physics, chemistry, biology and engineering. Various forms of engineering, be it be electrical, be it be electronics, be it be chemical, be it be mechanical, but various forms of these new technologies can be obtained if these people work together and develop new nanomaterials or nano-sized devices. If you see the growth of nanotechnology, these are some of the milestones which are there. So, starting around 1959, 1960, let us say, Feynman gave this idea of nanotechnology. Then we have lot of work being done on the development of nanomaterials, but understanding nanomaterials was still limited because the characterization tools were not available. Then came the development of scanning tunneling microscopes that allowed the imaging and manipulation of atoms, and there you could actually see how the atoms were arranged and how the nanomaterials had different atomic arrangements than their counterparts, which was seen in bulk. Then there was development of atomic force microscopy, Then came the discovery of various carbon structures having nano-sized morphologies, be it be carbon nanotubes, Buckminster fullerenes, be it be graphene in recent times, and now we are talking about new generation nanomaterials which are very different from carbon and also have different properties than these systems. The properties change in these nanomaterials, that is clear, but what properties change? The nanomaterials actually show enhanced surface to volume ratio of surface to volume ratio means the surface to volume of the particles which we are talking about. They facilitate reduced transport length for mass and charge transport. They have high specific surface area, low dimensionality. They can deliver high performance without the requirement of large amount of material. So, you can use low mass and still get very high properties, and that means you can reduce the cost of the devices. So, if you plot the surface to volume ratio versus the nanoparticle diameter, this is what the picture would look like. So, at very small scales the surface to volume ratios are high, and when the size of the particles increases, then the surface to volume ratios come down. Mathematically, let us say if you take a spherical particle having a surface area of 4 pi r square, volume 4 by 3 pi r cube, then surface to volume ratio would become 3 by r. That means this is inversely proportional to the radius of particle, that is given by r. This is how the increase in surface to volume ratio is explained. You can find out that these materials also have different melting properties. They have different electrical and thermal conductivity. The surface area changes, therefore, their chemical properties are very different, and as we saw in the first animation describing how we move from a bulk human hair to a nano sized slice of that hair, the mechanical properties are also expected to change significantly. We have also seen that the colors will change just by changing the size of the particles. It is not only true for silver or gold. This is an example which I am showing for cadmium sulphate. So, you go from 2 nanometers to 6 nanometers, and you can clearly see that the color can change significantly. Just to name some of the applications for these materials, they are ranging from energy, construction, optical devices, electronic devices, medical, construction, not civil construction, but construction of composite based aeroplanes. You have structures which are being used in Formula 1 cars, toys, your laptops. So, now you have these nanomaterials in nearly all facets of life. And as I said earlier, these are just a very selective example which I have put here, but you can just go on listing the areas where nanotechnology and nanomaterials are now being used. And I would suggest that you do this exercise. You will find that the list would be very long, and that would give you the interest to understand this course and what we are going to show you in next few weeks, that this technology and this course is very relevant for modern and future of mankind. In today's lecture, I have taken references from various places. Two major books which you can refer to are given here. Let me summarize what we discussed. We discussed the definition of nanomaterials and nanotechnology, the properties of materials and how do they change when we go from bulk to nano, and we listed some of the applications of these nanomaterials. I hope this introductory lecture will give you interest to pursue this course seriously, and over the next 12 weeks we will try our best to generate even more interest in you in the field of nanomaterials and nanotechnology. Thank you very much.